Hello, this is a short video about math, physics and simplicity in nature. And nature is a good place to think about. I'm a physicist. I've always been a physicist, and I was never particularly interested in math because I thought, well, might be a useful tool to understand nature, but the real thing is physics, right? And it turns out, if you look at the history of physics, that the development of laws is very much related to simplicity. Actually, many people have expressed this. Einstein saying that he cannot imagine a theory in physics which is not simple, and even Isaac Newton, who said truth, if ever, is found in simplicity, never in the multiplicity and confusion of things. But it's important that you realize that it's not just an ideology because simplicity is a fancy thing you believe to be true, such as beauty. Some people think about beauty in physics, which I don't think is a good criterion. Anyway, you try to define simplicity, and it turns out it's very much related to constants of nature. And as I explained in other videos, the big revolutions in physics always were linked to reduction in the number of fundamental constants. That means you understand something and you have less fundamental constants. Okay? But if you go back then, you realize it's not that simple from the beginning. That means even Isaac Newton made some arbitrary assumptions, and that causes a lot of trouble if you want to understand the fundamental laws. And the arbitrary assumptions of Isaac Newton were space and time. That sounds crazy, but everybody knows what space and time is, right? Really? But you can't take for granted that this appearance to our senses is automatically the most fundamental thing of which reality is built on. So that's a little bit how I became a mathematician, because if you're looking for the fundamental laws of physics and you think, and there is good reason to think, that simplicity is a guiding principle, you have to get rid of these arbitrary definitions of meters and seconds and space and time and ask, how could this structure arise from purely mathematical concepts? And it turns out that there is a very interesting, intriguing object in mathematics, which is the three-dimensional unit sphere. And well, it's not really difficult to understand, because this is the one-dimensional unit sphere. It's called S1. Here, S1. And it's defined in 2 dimensions by the equation x squared plus y squared equals 1. So of course you can go to the S2, which is something like the surface of the Earth, and you have x squared plus y squared plus z squared equals 1. That's the definition of the 2-sphere. And then you have, just go 1 dimension higher, and you don't call it x, y, z anymore, you call it a squared plus b squared plus c squared plus d squared equals 1. And this is a very interesting object, the 3-dimensional unit sphere. And remember, it's still a 3-dimensional object. In principle, you have 4 dimensions, a, b, c, d, but this equation restricts it to 3 dimensions. And there is a beautiful algebra and multiplication which was discovered by William Rowell Hamilton in 1843 in Dublin, and it has a lot of intriguing properties, and many properties really look like as if there is a close connection to the fundamentals of physics. But well, I will develop this in other videos. That's just a brief hint, and that's how I became a mathematician, because if you really want to understand the fundamental laws there's nothing else you can do.